Okay, fine. Let's start. Okay, is it okay to start now? Okay, I'm starting now.
Okay, sir.
Yeah. Last time we have seen how to design a frame, 2D frame, a regular frame, BC1 structure by using AISC code. Do you guys have any doubt? If you are okay with that, I'm going to take today class with Indian
Yes, sir.
Standard Code.
Sir,
Yeah. Yes,
I
tell
have
me.
doubt.
Yes,
How
tell
to
me.
given the wind load? Wind load. We have given only that load, live load.
Where?
Insta general frame modeling. We have done only that load or live load only, na, sir. Wind load we have to provide.
No. We have given wind load. Have anyone observed that one?
Sir, I have one question.
Yes, tell me.
How to find S1, S2? You have given a link, but in this link, not any
Sorry, I'm
data.
getting some
Any
echo.
data.
Rajendra Singh, I'm getting
Yes.
some echo. Can you please come out of the room? Please. I'm getting
Yes,
some
sir.
echo voice, right? Yeah. Yes, tell me, Rajendra Singh. Yeah.
Sir, I have how to find S1, S2?
S1, S2.
Sir, one question. You have given one link. ASC 7 करके कुछ आईडी वो दी थी सर आपने उस पे इंडियन डाटा अवेलेबल नहीं है
Sorry.
एक सेकंड जस्ट सेकंड सर
Okay.
सर
Yes, tell me.
You have given me a 1000 tools file link for
Okay. Yes. Yeah,
but
okay.
Indian data is not available in this.
No. S1, S2. That is not S1, S2. SS, S1. Okay.
Yes, sir.
I think you are talking about SS and S1. SS and S1 are spectral response acceleration parameters for short period and for 1 second.
Yes,
Okay. Okay. These are depends on the locality. Okay. Last time we have seen the locality in USA, right? That is only just an example. Okay. Last time we have seen a locality in USA because here in this tutorial, in this session, there are different kinds of people. Some may have projects, some may get projects from USA, some may get projects from Qatar, some may get projects from India. So that is why I want to cover all the localities. Last time we have seen the location in USA.
Yes.
Actually, SS and S1 values are given for localities in USA as well as UAE. Okay. But we don't have SS and S1. That is why we are going to use, what can I say, IS 1893 load. In that, zone factors are available for different localities. That is why I have to discuss now Indian code, how to design a frame using Indian code. I'll discuss now.
Okay.
Any other thing?
No, sir. Sir, I have sent 2 files for checking.
Okay, actually, I'm working now. I have to get time. Okay. After the probably today or tomorrow, I'll check your files and I'll let you know. Okay.
Okay, sir. Sir, one question.
Yes, tell me.
Sir, how to check column deflection in x direction or local x direction?
Sorry.
Column deflection.
Okay.
In which direction will be checked?
No, actually, what happens? Only x direction only we will check if it is column, because column may deflect laterally, right? Beam
Yes,
or
sir.
rafter will deflect vertically.
Vertically.
Yes, that is why column will be checked for lateral deflection, whether it is caused due to seismic or wind.
इसमें और डेड लोड और लाइव लोड के लिए नहीं चेक करते थे इसको.
Sorry,
डेड एंड लाइव के लिए चेक नहीं करते इसको. It will be
for column you are asking.
yes sir.
For serviceability condition, we will check for all the combinations.
Yeah, okay sir.
Okay, if you check for independent loads, you have to check for either seismic or wind. Okay, for serviceability combinations, all the combinations must be satisfied. Clear?
Okay sir.
Fine. Any other thing?
एंड सर सर एक इसमें
Yeah.
कॉम्बिनेशन और है.
क्या
इसमें डेड प्लस लाइव, लाइव प्लस कोलेट्रल एंड बोथ कॉम्बिनेशन आर नॉट टेकन.
Where?
Dead plus live plus collateral.
Okay.
This combination will be created in this file in ASC designing. ASC.
Yes. ASC design. Yes.
Can be create load load combination dead plus live, dead plus collateral, dead live plus collateral.
Yes, exactly. I'll clear your doubt. Actually, what happens in AISC LRFD, if you go through LRFD, there are combinations for deadline live, that is 1.2 and 1.6. 1.2 dead load plus 1.6 live load case combination available. If you observe AISC combinations, there are no particular combinations for collateral load. That is why whatever the load factor available for dead load, that is the same thing we have to consider for collateral load. That is why there is no special combination for collateral load.
Okay, sir.
Okay. Fine. I am starting this class. Okay. If you have any doubts at the end of this class, we will see. Okay. Just let me start my class. Okay. I'm sharing my screen. My screen is visible to you?
Yes, sir.
Okay, fine. I am taking a new structure. Just give me a name. Indian code mezzanine frame. Okay. Okay. Last time we have discussed and agreed that I'm going to take you through all the different types of structures, that is regular frame, mezzanine frame, crane beam along with frame, and flat roof frame, and 3D structures. Okay. So each and every structure I want to use different codes so that all the codes and all the types of structures will be covered. So last time we agreed that one. That is why we have seen last time AISC design using AISC code, and now design using IS code I am sharing you, and that is this frame is with mezzanine. Okay. For this purpose, I want to take one example. Okay, fine. Let me take this example. Actually, you are seeing my screen, right? This
Yes,
is
sir.
the 55-meter wide building and 84.5 length building, and I am taking a mezzanine frame. That is why I am taking grid line 2. Okay, I am taking grid line 2 in order to explain a frame with mezzanine. So, can anyone guys, what is the tributary length for grid line 2? My screen is in front of you. Just it is a simple thing. Try to answer. What is the tributary width for grid line 2? So many sessions happened.
So 6.3.
5.375 meter.
Yeah.
5.5 meter.
6.3 plus 4.45 divided by 2.
2.
5.375, right?
5.375. Yes, sir.
Yes. So make sure to remember this. I am going to take this frame in the design. What is the width here? 55. I just want to assume that the block wall thickness is 200 here. Okay. Here also it is 200. So overall 55 meters minus 400 mm block wall, and STAD will do design along the center line only, right? That is why you have to assume the center line of the column at the base. Okay, suppose I am assuming that the base depth of the column is 300. So what will be the center line here? 150. So one side it is 200 plus 150. The other side also I am assuming 200 plus 150. Is that clear to all of you? I am assuming that my base depth of the column is 300. Okay, this one at the base is 300. So what about the center line? Center line will be passing through the center of the web. Okay. So 200 block wall plus 150 center of the column. So 350 on one side. On the other side also it is 350. So overall, in order to give perfect geometry in the STAD, what you have to deduct from the actual width? 55 minus 0.7. Or all of you agree with me?
Yes, sir.
Right. So 55 minus 0.7, which gives you 54.3, right? So I am giving first node here, and the second node. Before giving to the second node, I am changing the view to front view in order to get easy visible. So I'm selecting the first node, Control C, Control V. You have to give the X distance for the second node, that is 54.3, which we have discussed now. So these grids are created. Which grid? A and L are created. Now you have to give the height. So what is the height of this building? For example, if you take this one, 6 meter clear height you have given. They have given, for example, customer has given 6 meter clear height. So what is the module? Module means clear span between the columns. Okay, span between the columns can be called as module. Okay, so what is the module here? 27.5. Based on that, you have to assume the maximum rafter depth at the haunch portion. So what you can assume, suppose I assumed it as 800. Okay, basically I'm again telling you STAD, whatever you have designed, you have to design in the STAD, that is all trial and error process. You have to give some value. You have to check whether it is passing or not. If it is passing, then okay. Otherwise, you have to change the section in order to pass, right? So I am assuming the section, depth of the rafter is 800. So what is the center line for me? 400 only from the top of the rafter. So he has given 6 meter clear. Clear means bottom of the rafter. I am assuming 800 depth of rafter. So 600 plus center line will be 400, right? For 800 rafter, center line will be 400. So 6.4. Do you guys agree with me?
Yes, sir.
So Control C, Control V. I am giving height of 6.4 for 2 nodes. Okay, these 2 nodes has pasted at a height of 6.4 meters from the base plate level. Sorry, and the thing is that there are certain columns here. If you observe, there are some columns here. Okay, so I want to take this column in the stat. So this is 5.5. Already we have deducted this 200 plus 150, right? So that is 0.35. 5.5 minus 0.35. 5.5 minus 0.35. That gives you 5.15 for first column. 5.15. And if you observe all these columns at a distance of 5.5 meters, right? So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8 columns at a distance of 5.5, right? So there is one command I already told you in the basics of the stat session. First one, you have to select the node, and then there is a particular feature that translational repeat. Okay, translational repeat feature is there. This translational repeat is a feature that can repeat the node at a particular distance given by you. So I want to repeat the node in particular x direction for every 5.5 meters. That is why I have selected in x direction. Sorry, I have selected one node and I have taken this feature. I have selected x direction. My default step spacing is 5.5 meters. And how many steps you need to take? 8 steps. And click on OK. If you observe, I have produced nodes at every 5.5 meters. Check this. Here also. And the last one will be again 5.15 because we have deducted 150 for column and 200 for block wall. Right? That is 5.15 both these. So it has completed. Now you have to give peak height. Peak means this is the one. Okay, this is the one. Okay. So has he given anything here? No. So I am taking the roof slope as 1 in 10. Okay, I am taking the roof slope as 1 in 10. So what is the distance between these nodes? It is 54.3. For symmetrical ridge, where will be the ridge located? 54.3 divided by 2, that gives you 27.15. So I am selecting node cursor. I am selecting the node. I am pasting the node. Control C, Control V. At what distance you need? 27.15. I am assuming it as a symmetrical ridge. Okay. And if I assume it as a 1 in 10 slope. Sorry. Anyone have any doubt? No?
It will be rise 2.715 meter.
Yeah. 2.715. Right. That is the rise. Okay. This is the rise and this is the x distance. Okay. If you click OK, if you can observe the node is created here. Okay. The x distance between these two nodes is 27.15 and y distance between these two nodes is 2.715. That is 9.115 minus 6.4. If you do, that is 2.715. The node is created here. Okay. I am I'm displaying all these dimensions. So geometry is created, and the one more thing here you left is you have to give mezzanine at a particular height. If you observe this thing, I have taken 3.1 TOS. Okay. 3.1 TOS means 3.1 height, top of steel. Okay, top of steel, that is top of mezzanine beam, you can say. Okay, these are mezzanine columns. The horizontal one you are seeing is mezzanine beam. Here customer has requirement of 3.1 top of steel. Top of steel means top of mezzanine beam. I'm getting some disturbance from some of you guys. Can you please mute yourself? Okay, clear. So this is 3.1 from the base plate level. Okay, so I'm just taking all these nodes, Control C, Control V. Before pasting the nodes, what should I do? I'm taking a calculator here. So okay, 3.1 is the top of steel minus, if you assume, actually what is the beam span here in this 5.5. So based on the experience only you will get these assumptions. Okay, whatever the depth may come for this span, you'll get all this based on the experience. Okay, for 5.5 generally what may be the mezzanine beam depth is around 600. Okay, let us assume the depth of the mezzanine beam is 600. So 3.1 minus 0.3, that is because STAD will take center line dimensions. So if the beam depth is 600, you have to give 3.1 minus 0.3 for center line. Okay, 600 by 2, that is 300, right? So you have to deduct that 300 from TOS. 3.1 minus 0.3, that is 2.8. So I am copying these nodes at a y distance of 2.8 meters. So I have produced all these nodes. So it is completed. Now I am taking add beam feature here. So I am joining these nodes, because in any PEB you have to divide the rafter into particular number of segments so that you can optimize much more. Okay, in order to divide the rafter into particular number of segments, I have selected the rafter, and there is one option called insert node feature. Okay, insert node feature. So this is generally what we have seen. Generally any company prefers to divide the segments in the multiples of 3. Okay, divides the rafter in the multiples of 3, because some companies may follow 9 meters transportable length, some companies may follow 12 meters transportable length. All these numbers are in the multiples of 3. So most of the companies will follow the segment in the multiples of 3. So that is why I am taking multiples in 3. First one is 3, second one is 6, 9, 12, 15, 18, 21, 24. So actually what is the beam length here? It is showing 27.2824. So you have given up to 24. So what will be the next number? It is 27. Already there is 27. So no need to give. Click on OK. So you can see this rafter is divided into number of segments. So you can see different nodes are created along the length of the rafter. So there is one more feature, because this is a symmetrical frame, you can mirror these nodes on the other side. So whatever the nodes you want to mirror, you have to select the nodes, and there is one option here, you can see mirror. Okay, if you click on mirror, which plane you want to mirror, it is asking. So the nodes is here, so the mirror line will be like this. What is the line here? YZ plane. So you have to select YZ plane. and along which node you have to mirror. So this is the center node for these two lines, these two rafters. So I am selecting that one, and if I click on OK, the nodes on the one side will be mirrored to the nodes on the other side. Is it clear to all of you?
Yes, clear.
Okay. I am deleting all these beams. It is asking 18 beams and associated physical beams, if any, will be deleted. Click on OK. It is asking if you want to delete the nodes. No, I want the nodes. I have deleted the beams because I want to give the beams in a particular number. Okay, if you want, you can do without the number. That is not a problem. But I want to go through a particular ascending or descending order according to the number wise. Okay, that is why I have deleted the automatically created beams. I want to give it by my own. Okay, so I'm adding the nodes by using add beam command. So if you want to see the beam numbers, shift B command is shift B. You can see the beam numbers here. Okay, 1, 2, 3, 4. Columns completed, and I'm joining the rafters 5, 6, 7, 8, 9, 10. Sorry. Okay, then we go to the cross section. So we have created beams along columns and rafters. Now what is the remain here? One center line, that is BC column, is remain in mezzanine beams and mezzanine columns. So this is the BC column. BC column completed. In mezzanine columns, these small columns are called mezzanine columns because they are supporting only mezzanine, not the complete structure. Okay, so these are not mainframe columns. These are called mezzanine columns. So mezzanine columns also completed. Now there are mezzanine beams. Now is it clear to all of you how to model a frame? It is okay. Now I am going through the next process. So generally most of the structural engineers will prefer the method by using STAAD editor. Okay, why STAAD editor method is preferable? Because you can change the dimensions easily. Suppose if you want to change the properties of this beam, you have to double click, go to the properties section here, and you have to change the database here. All these are very lengthy process. But if you have STAAD editor, directly you can change the numbers by using typing. That is why most of the structural engineers prefer to use STAAD editor method. So make sure and be habituated to the STAAD editor method. It is very simple, not at all difficult. Actually, what here anyone can do. Here anyone can do. You can give the beam command. You can give the whatever the specifications you can give directly. All these are visible. Anyone can give. No need to be a structural engineer actually. So if you want to be a perfect structural engineer, go to the STAAD editor. Okay, so if you habitate to the STAAD editor, you will experience that it is simple. Okay, so just before going to that, I am assigning the material steel. to the model, whatever I have modeled here. Okay. So I am going through the stat editor. So, okay. Stat editor symbol, you know, right? Paper and pencil symbol is there, no? At the top, you can create, or otherwise you can create in the space shortcut. Okay, in the stat basics itself, I told you there are some certain shortcuts available. If you are in the user interface, if you click the space button, there are some certain shortcuts will open here. If you want to change the shortcuts as your wish, there is one shortcut here, customize quick commands. Okay, if you click that, whatever that you need, you can move it to the right side. Whatever you don't need, you can move it to the left side. Okay, like that you can do. Okay, if these are not visible to you, go to the analysis. What is that? Yes. Okay, or otherwise you can create here analysis command file. Generally this is called command file. Okay, paper and pencil symbol, that is command file editor. You can see if you roam the cursor on this, you can observe this is command file editor. Okay, that is command file. If you click this, automatically it will come at the top. Okay, so by using that also you can enter the stat editor. Okay, first thing you have to do is that you have to check whether you are doing space frame or 2D frame. I am doing 2D frame. Okay, generally all the PEB companies will prefer to use 2D frames because 3D frames are time taking frames. Okay, 3D are mostly time taking. So what is the advantage of 2D? If you do 2D and if there are similar frames available, you can multiply the number of frames. Like that you can estimate. Okay, that is why most of the PEB companies will follow to do 2D frames only. So if you do 2D frames, what is the command you need to give here? Can anyone guess? Last time we have seen
Plane.
Yes, exactly, plane. So this is the one you need to change because we are doing 2D structure and the loads will be applied along the X and Y directions only. There is no structure along Z direction and there are no loads applied along Z direction. That is why it is going to be a plane frame, that is 2D frame. So I have done this, and if you observe the default units created here are meter kilonewton. Okay, generally while configuring the stat pro if you are new to the stat pro, if you have newly installed in your system, it will ask directly whether you want to use English units or metric units. Okay, English units means pounds, inches, etc. all these things in generally inches. Okay, so I have selected metric units, that is why it is coming meter and kilonewton by default here. So okay, so we have applied material steel, so that is why material properties came here, and then I want to give the properties to all these things. So for that, okay, this is the main advantage of stat editor, because if you want to give properties to every section here, okay, so if you go through the UI interface, user interface, so it takes much more time because you have to select each beam, you have to create every section, and you have to assign every section to that particular beam. So it is time taking process, no? If you have stat editor, you can simply write commands. Okay, so I'm changing units to mm's kilonewton, because if the units are in meter kilonewtons, you have to give the properties of the sections in meters. That is, if the flange width is 200, you have to give 0.200. Okay, by mistake, if you miss 10 before the any decimal, if you miss any decimal, that will create a lot of difference, right? Suppose let us take 6 mm thickness of web plate is there. So if the units are in meter kilonewton, so the actual thing you have to give it, if it is 6 mm, you have to give 0.006 like that. Okay, by mistake or overlook, you have given 0.06 like that. So what is that? It is going to take 60 mm thick, 60 mm thick of web plate like that. So it is so much high, right? So that is why I'm changing the units to millimeters kilonewton. You can directly give here direct values, right? So you guys agree with me in this concept? Or if you want to go through meter kilonewton, I'll explain the concept in meter kilonewton. It's your wish, guys. Nothing to do wrong at all. It's completely your wish. The program will allow you to do in any way. It will not object you to in this way only, right? So is my concept is clear to all of you? Yeah, because CAD editor has a flexibility to change units in any intermediate concepts. Okay, you can change units wherever you want. That is the flexibility with CAD editor. So I have changed the units to meter kilonewton. Now I am going to assign the properties to the particular beams. For that, I am going to take member property Indian. So member property Indian. Last time we have seen member property American, whereas we have seen AIC design. In this, we are going to do Indian standard design. That is why I have taken member property Indian. Okay. So member property Indian. Okay, fine. Units are in mm and kilonewtons. Because this is a symmetrical frame, so the properties for 1 and 3 column numbers 1 and 3 will be same, right? This is a symmetrical frame. If you have unsymmetrical frame, you have to give different properties. Okay, sometimes you can get the thickness of this column will be higher, this column may get lower, like that you have to give if it is unsymmetrical. Or if you have any what I can say, if you have any different block wall load conditions, block wall conditions means actually in our example, if you go to the example, it is full height block wall. You can see what I have got here, full height block wall. You can observe on the both sides. So this is symmetrical. Suppose if you have 3 meter block wall and sheeting over there, and if you have full height block wall here, these two columns will be unsymmetrical. Okay, but in my case, in both sides also, I got full height block wall. So if you have some height of block wall and over that sheeting is there, and if you got full height block wall on the other side, the columns will have different sections. Okay, because LY, UNT, UNB will change as last time discussed. LY means unsupported length along the minor axis, unsupported length of the top flange, unsupported length of the bottom flange. All these conditions will depend upon the support conditions. So from where the column has to take support, the beside there is whether it is block wall or whether it is sheeting. If there is sheeting, we need to provide secondary members like guts. So guts will provide some sort of support to the column. So, but in case of block wall will be leaning over the column. It itself leaning over the column. Because of that, it will not provide any support to the column. Okay, block wall will be leaning over the column, so it will not provide any support. Okay, it will take column support. Block wall itself will take column support, but it will not provide any support to the column. If there are guts will be connected to the column, right? So it will provide some sort of support, but there are no guts here. So full, so whatever, what will be the ly un to nb, we will see here. So because the frame is symmetrical, I can give the same properties for both side columns. Okay, means 1 and 3 will have same properties. 1 and 3 tapered. So all these things we have to assume. Okay, you'll get all these things based on the experience. Okay, because whatever we do is in the STAD is trial and error process. I'm again telling you, STAD itself will not design by its own. Okay, you have to give some section, it will check whether it is passing or not. That's it. So I'm giving 800 top. Okay, nothing but at the top of the column it has 800 depth. So if the web has 800 depth and the flange, suppose assume flange thicknesses on either side is 1010. So what will be the overall depth of the section? 820. Suppose let us take web thickness as 6 and the second depth. Okay, second web depth. Okay, this is the starting web depth or first web depth. This is the ending web depth or second web depth. If you roam a cursor or the particular beam or column, it will show green and blue lines. Green will be the starting point and blue will be the ending point of the beams. So 820 will be the starting point, that is at the green portion. The next depth you are going to give is at the ending point of the beam, that is at the blue portion. So suppose you if you take suppose there is 500. Okay, 500 second depth. So overall depth is 520. Outside column flange width is 200 and the thickness is 10. Inside to column flange is 200 and thickness is 10. Clear? 2, 4. So what will be the starting point of 2? Whatever the depth at which 1 has ended, the 2 will start there. So it has ended at a depth of 500 web. So it also has to start at the 500 depth, right? 525, suppose 300 at the base. We have this, we have assumed, right? 300 at the base, 200 outside flange width and 10 outside flange thickness, 200 inside flange width, inside flange thickness 10. So this syntax have you got habitated? This is the starting web depth, thickness of web, ending web depth, and outside flange width. Just zoom in for your convenience. Okay, this is the outside flange width, outside flange thickness, inside flange width. Sorry, inside flange thickness, right? So this is how the syntax will work. So I have given properties for columns. Whatever the line you start with star, that will not run in the program. Okay, so this is like comment line. Okay, this is called comment line. This is only for reference purpose. This will not run in the program. This is for your understanding I'm providing. Okay, columns have been completed. I can say main columns. Okay, main columns have been completed, and I'm going to take rafter properties now. So rafters of 5 and 22 will have the same. Sorry, 5 and 22 will have the same depths, right? Suppose this is also starting at a depth of 800, 800, 700, 210, 210. You guys, if you have any doubt in this syntax, you can ask me. Okay? No, don't hesitate to ask the doubt in the syntax because it is very important. If you miss one thing, it will change the entire property of the section. Okay. 621. So in the standard data, it is the another flexibility, right? You can copy this syntax and paste it for another member. Suppose 8 and 19, right? 8 and 19, yeah. So control V, just suppose this section is constant from here on. Suppose, for example, I can copy this syntax and you can paste it to every member, whatever having similar properties. 9, 18, 10, 17, like 11, 16, 12, 15. So suppose here 13, 14. Sorry. So here it has started with has starting depth of 620. So here it will get 620. And just I told already in the last class.
10% slope.
Sorry. Yes, exactly. Yes. So for the remaining people understanding, generally this is the BC column, right? BC column can be fixed or pinned at the top. But if you want the proper connection, if you want to sit the BC column properly below the rafter has to be like flat bottom. Okay, if you want to maintain the rafter flat bottom, actually what is the length of this member? Length of this member is 3 meters. And if you want to give flat bottom here, okay, roof slope 1 in 10, you cannot change like that, right? So if you want to provide a flat bottom here, so here I have a start depth of 600. So end depth, how you have to provide end depth in order to get flat bottom. So just see my calculation. The member length is 3 meters into 1 in 10 slope, 1 by 10. That is how you got, that is 0.3 in the meters. So 0.3 in the meters, if you convert it into mm, you'll get 300 mm, right? So if there is change in depth of 300 from the starting to ending point, then only you will get flat bottom. That is the actual meaning here. Okay. So yeah, I have a starting depth of 600. So what depth I have to provide here now? 900, right? So how to change the thicknesses, all these you'll get by practice, all these things. Okay. So here rafters also completed. Now internal columns I have 23 tapered. Suppose 400 depth of column is there. Okay, 425, 420, 210. Okay, 24 also tapered, 425, 420, 210. Then you will get doubt actually. So sir, actually why you have given 23 and 24 separately?
Because of mezzanine, I think.
Yes, exactly. Because of the mezzanine, the bottom section, nothing but 24, you may have get higher section than the 23. Okay, this is, I have assumed this section I have given here. After the analysis, you will get to know whether this section I have given is sufficient or not. Okay, anyway 23 will not have this much have section, but 24 might not pass with this section. That is why I have given two different properties here for 23 and 24. Now internal column completed. I want to give mezzanine columns. So why I am telling you like that? If you go to the numerical order, then only you will not miss any section. Okay, if you observe 1, 2, 3, 4 completed here, 5 to 22. If you observe completed here, the next thing I have is 23, 24. this is the advantage. What is the advantage of doing like this? You will not miss any section. Okay, so I have completed 23 and 24. So 25 onwards, measuring columns will start, right? So 25 tapered, suppose 300. 325, 320, like this. So Control C, 26. Sorry. Right. So if you observe, 29 will be the mirror of 28, 30 will be the mirror of 27. So all these sections can be similar. 28, 29, 27, 30, 26, 31, 25, 32. So measuring columns have been completed, and now it is up to mezzanine beams. So just what is the depth of the section I have assumed at the time of modeling? It is 600, right? Mezzanine beam depth I have assumed it as 600. That is why I have deducted 0.3 for the center line in order to get the mezzanine beam in the stat, right? 33, 42 have similar properties. Suppose just this is assumption only. Just in order to give demo to you, all these sections are with 210. Actually, these much of sections not necessary. You will get optimization anyway. 34, 31, 35, 40. This is the advantage of stat editor. You can copy and paste directly. 37, 38. So any sections remain here? No. So all are completed. So if all are completed, then what is the next step?
Support.
Yes, support. So already we have constants here. After that, supports. So sorry. So in order to get the supports, you need node numbers. So what you are seeing now are beam numbers. So if you click again Shift B, these beam numbers will disappear. If you want node numbers, you can click Shift N. So 1, 2, 5 to 13. Right? 5, 6, 7, 8, 9, 10, 11, 12, 13. 1 to 5 to 13. 1, 2, 5 to 13. What is the support I'm giving here? Pinned support I'm giving. And after that, actually, what is the default? What is the default unit here? Meter kilonewton. For my convenience only, I have changed this to units mm kilonewton. Now, giving the section properties has been completed. Now again, I'm returning to particular default units. Okay, units meter kilonewton. Now, what is the next step we need to give?
Earthquake. Define it in
No,
93.
yeah, particularly loads. Simply loads, right? So loads. Generally, we have seen different types of loads on a PEB. So earthquake loads and dead loads, gravity loads like dead loads, live load, any other collateral load. So in the Indian code also, there is no particular definition for collateral load. Okay, so you can say dead load and gravity load come under live loads. Dead load and live load come under gravity loads, and then you have wind loads. Actually, for the temperature, we don't have any particular load combination in the Indian code design. Okay. What will happen in the practical cases if customer wants to consider temperature load? Okay, if customer wants to consider the temperature load, by default it will be 27. Okay, if customer wants to consider the temperature load, by default it will be a 27 degrees Celsius. So what is the load factor? Sorry, what is the partial safety factor for the temperature is the same thing as dead load. Okay, suppose you have dead load factor is 1.2. Okay, the same thing will be applied to the temperature also. So in the practically we'll provide like that. But if you have any so when the temperature will matter, actually when the temperature load will matter. So if you have any polar regions, okay, polar regions like what I can say, like North America, right? North America. In like that locations, you will have rapid change in temperature. Sometimes it will freeze. Sometimes it come to room temperatures. Or if you have any particular high temperature areas like deserts, like what we can say, or if you see UAE, there are rapid temperature changes. Okay, because there will not be any snowfall there actually in the UAE. There may be a chance of getting higher temperature. Like all these locations, temperature load must be there. But in our India, there will not be any rapid change in temperatures. You can observe. Have you observed any freezing temperatures in India? Except like something, sometimes some portions of India, like North India, if you observe Jammu Kashmir like that, you can observe some sort of snowfall. But remaining India will not have any that much of temperature, rapid temperature changes. That is why generally for Indian projects, we will not consider temperature load unless otherwise customer has asked. Clearly? Clear? Is it clear?
Yes, sir.
Yes.
Clear, sir, clear.
Clear. So because we don't have any that much of freezing temperatures, or otherwise we are not getting higher temperatures like West Indies, like that, right? Because we are not in the polar regions or away from the polar regions. We are almost at the center line, right? That is why we don't need to consider temperature load. Generally, if you consider temperature load also, that will not show any effect. Okay, unity check ratios will not change much. Okay, suppose you got 0.9 without temperature load. If you apply temperature load, that may get changed to 0.901, like that, nothing but 0.001, like that ratios may change. That is why in Indian codes, temperature loads may get neglected if customer has not asked. Okay, so I'm going to start taking loads here. First of all, what is the load I have to give? In before going to the loads, you have to define the seismic specification. So what is the seismic specification we have in India? In Indian?
1893.
Yes, exactly. So that is the same thing I'm defining here. Define 1893 load. So there are some certain parameters I'm going to write here. All these things I will explain. So first one is Z. Z is nothing but zone. So just in the last, I think we have seen this, right? Seismic calculations we have seen in the last previous classes. So I'm going to take the same data. Suppose, okay. what is the zone factor? Already you have seen in the seismic calculations, seismic zone factor is 0.1. This is the example I am taking. Okay, this is based on the location, based on from table 3. Okay, IS 1893 table 3. If you go through table 3, you'll get zone factor for different locations. Okay, zone factor is 0.1 here. The same thing I'm mentioning here. And the next thing, RF. RF means response reduction factor. Simply, they have given RF. Right? RF is response reduction factor. What is the response reduction factor we have got here in our example in the previous class? We have got 3. The same thing I'm taking here. And the next thing is importance factor. So all the things I have in my data, I have given one Excel sheet to all of you. In that, all these things I have. So the same thing, importance factor 1. If you observe this line, 24th line, importance factor is 1. And soil class, SS is nothing but soil class. Okay, generally in STAD, how the soil class is defined, one is for hard rock, and the second one is medium stiff, and the third one is loose soil. Like that they have defined. So if I take, based on the soil property, if I take medium soil, I have to give 2. 1 is for hard rock and 3 is for loose. Like that, SS2. And DM is nothing but damping coefficient. Generally, this is depends on the locality. If they don't have local data, all the Indian projects will be defined for 5% damping. 5% means 0.05. So the next thing, what you have to give, weights, seismic weights. Okay, before going to the seismic weight, you have to include the self weight of the structure in the seismic definition. Self weight. So the factor is 1. Okay, someone has unmuted. Please mute yourself. Okay. So okay, some people will follow factor of 1. Okay, some people will follow factor of 10% extra, 1.1. Why? Because this is just a skeleton. If you observe, this is just a skeleton, right? Like only frame. We will not have any guards, purlins, or what we have in the real time, sheeting or any other accessories, like, right? So we will not have all these things in the STAD. That is why practically some people will give 10% extra. Sorry. And the next thing, we have seismic weight. We have some formula here. So what we have, dead load plus some type of percentage of live load into tributary area. So dead load, already we have seen, if you consider it for roof, okay, generally code will not provide any seismic weight for live load, seismic weight percentage for live load. So that is directly you can give dead load into tributary area, because this live load percentage will be 0. Okay, if you go through the class 7.4, that is seismic weight. Okay, there is no provision for roof live load. Okay, you have 25% of provision for mezzanine live load, but there is no provision for roof live load. Okay, so roof live load percentage share will be 0. So only dead load will govern there according to the class 7.4. So just I'm writing here formula also for your convenience. Okay. Roof seismic weight is equals to dead load plus 0 into live load. I can say roof live load. Okay, RLL. For your convenience, I'm writing like this: 0 into roof live load into tributary length. Okay, tributary. So in our example, what is the dead load here? So 0.3 plus 0 into 0.6 into what is the tributary? Just at the starting of the class we have calculated something like 6.3 plus
5.375.
yes 5.375. So what is the value you get here? 0.3 plus 0.3 into 5.375. This is 1.6125. Okay, this is the seismic weight of the structure. And now I'm going to take mezzanine also, right? So mezzanine seismic weight is equals to mezzanine dead load plus 25% of the share. If you go through the class mentioned in 1893, 25% of the mezzanine live load share will be there into tributary. Okay, so mezzanine dead load, I have any data in my example? No, I think I have not taken here in our example. So let us assume, okay, since all these are practical sessions, I can assume this one. Okay, suppose mezzanine.
Sir, I have a doubt.
Tell me.
Sir, after define 1893 load, we are giving sulfate of structure.
Yeah.
Why we are not giving any sign?
Which one?
Plus minus.
Yes, this is a perfect doubt actually. Why I am not giving any particular sign? This
Yes,
doubt
sir.
will be clarified just after this step. Okay, just be patient till this step. Okay, I'll tell you why I'm not giving the sign convention. Okay, yeah, I am assuming mezzanine dead load of something like 5, or you can say 4 kilonewton per meter square. Mezzanine live load is equals to some like 5 kilonewton per meter square. So I'm applying these loads for mezzanine seismic weight. So dead load is 4 plus 0.25 into. Okay, don't worry about all these loads. This will be given by customer according to the occupancy. Okay, so for what purpose he has going to use that mezzanine? So depends on that. He will give you, customer will give you all these loads. Okay, so dead load. Yes, tell me.
Sir, what is the dead load of concrete?
Sorry.
What is the dead load of concrete?
Okay, fine. Yes, exactly. Okay, in this only I'm going to explain you. For example, I am having suppose 125 mm thick slab.
Yes, sir.
Okay, 6 inch something, right? So 125 mm thick slab, for example. So what is the unit weight of concrete here? 25 I am taking into 0.125. Do you agree with me? This is 125 mm thick slab. If I convert it into meters, this is 0.125. Actually, what is the units here? 25. What is this? Unit weight of the concrete. What are the units for unit weight of concrete?
Kilonewton per meter cube.
Yes. Yeah. Agree with me?
Yes.
So 25 into 0.125.
Yeah, agree, sir. Agree.
Got it. Yeah.
3.125.
Just a minute. Let me calculate. 25 into 0.125. Yeah. 3.125. This is in kilonewton per. So meter cube into meters. So this is a numerator. Okay. Sorry. 125 mm thick. This is the thickness. Thickness is only length parameter, that is in meters we have given. So meter by meter cube you will get meter square. Clear? So this is 3.125. So you will get doubt. Sir, actually you got dead load as 3.125. So why you have taken 4 kilonewton per meter square? So there are some sort of finishings will be there, no?
Yes, sir.
Okay, some sort of finishings or flooring, something will be there, right? So based on all these things, I have rounded it to 4.
Okay, sir.
So okay, 4 plus 0.25 into live load. Live load, what I can take? Live load is 5, right? Yeah. Into tributary 5.375. 4 plus, sorry.
28.21.
Okay. Sorry. What? 4 plus 0.25 into 5 into 5.375. This is yes, 28.218. Yeah. So this is how you have to calculate the mezzanine weights, right? After that, you need to give member weights. So you have calculated this one. Now you are going to assign this to the particular members. So just concentrate this thing. I am going to display again the beam numbers here. So roof seismic weight. Roof seismic weight will be applied for rafter, and mezzanine seismic weight will be applied for mezzanine beams, right? So in the mezzanine weight command, I need to give only rafter members, that is 5 to 22. Here also, please you can observe, I'm not giving any direction, whether it is X or whether it is Y or whether it is Z. I'm not giving any particular direction of the load. Just I'm mentioning the type of load. UNI means uniform loading, UDL. In simpler term, you can say it is a UDL. But I'm not mentioning the direction, whether it is Y, negative Y, positive Y, negative X, negative or positive X, like that. I'm not mentioning here. Just I'm mentioning the type of load. So, and the intensity of load. Because I'm taking the rafters, what is the intensity? 1.6125, right? And for the this mezzanine beams, 33 to 42, you need, what is the value here? Intensity of the loading, 28.218. So till this it is clear. Why I have taken 5 to 22 here? Why I have taken? Yes, clear. Thank you. So seismic definition has been completed. Now I am going to take primary loads here. Primary loads, load 1. Load 1, I am going to take seismic positive X. So someone asked just 5 minutes ago, why we are not giving direction in the self weight or member weights. So this is the doubt, right? Now I am defining the direction here, load application. This is not the load application. This is assignment of load. Okay. Now this is the definition, completely definition. I have defined one load. So what is the intensity of the load here? I have defined here. Now I am assigning the load in the load case. So how it will be?
Okay, sir. Got it,
Sorry,
sir.
got it?
Yes, sir, got it.
Yes, thank you. Now load 1 seismic plus X, 1893 load. Which load it is? What load we have defined here? 1893 load. The same thing I have defined here. In the 1893 load, how you want to apply the load? If you observe here, I am taking positive X. This is the name. This is the name. Just what is my name? My name is Ganesh. What is someone's name? Rajendra Singh Yadav. Like that. This is just a name. This will not provide any direction or provide any information in the design. Okay, this is just the name. Now I am defining the direction here in X direction in positive 1. Clear? Next, what thing I have to do? Perform analysis. Perform analysis and change. Why I am giving these two commands? So perform analysis and change, because I am going, just I'm getting some disturbance here. Okay. Sorry guys. Yeah. So I am giving perform analysis command and change command. Why? Actually, I'm going to apply another seismic load, right? So this is in positive direction, and the second case I'm going to apply in negative direction. If you do not change this, okay, these combine to get neutralized, right? Did you guys understand my point? This is positive one. Suppose it is applying in this direction. If you do not provide change, and if you apply second load, it is in this direction. So positive and negative, what will happen? It is going to neutral, right?
Yes, sir. Yes, sir.
Fine. That is why I have to do the perform analysis, and I have to end this load with this case only. With this case itself, I'm going to end this load. I'm starting fresh load again. Load 2 seismic negative X. Now, clear? 1893 load. Now X in negative direction. Sorry, X minus 1. X in negative direction. Perform analysis. Sorry, change. Right? So this has completed. Seismic loads has been completed. Now the load 3 is, so what is the next load?
Dead load.
Yes, dead load. Load 3 is dead load. So for the dead load, I'm just writing some notes for your understanding. This is, I can say, roof dead load. Whatever the value given by you, given to you by the client, you can use that value. Dead load I have is 0.3 here. Okay, this is all including sheeting and purlins. Suppose let us take in our example. So 0.3 into what is the tributary here? 5.375. So if you observe, this is in kilonewton per meter square. Okay, this is in kilonewton per meter square in our example. So I'm multiplying it with meters. If you want, then I can write here also kilonewton per meter square into tributary meters. So you are going to get UDL, right? 0.3 into 5.375. That is 1.6125 kilonewton per meter, right? So where it has to be applied? From members 5 to 22. Roof dead load. Roof dead load means you have to apply it on the rafter, right? 5 to 22. Before applying it to the rafter, which load? Under which load it will come?
Member
Yes,
load.
member load. Member load from 5 to 22. Which type of load it is? Uniform load. Uni. In which direction? Gravity. Gravitational downwards, right? So global y direction. Negative. Negative means downward direction. Minus 1.6125. Clear? Now I'm taking mezzanine dead load. So mezzanine dead load I have is 4 kilonewton per meter square into 5.375 meters is my tributary. And so what is the intensity of UDL? I'll get 4 into 5.375. So that is 21.5. 21.5. Sorry, kilonewton per meter. You will get. So from where it has to be applied? From member 33 to 42, sorry, 33 to 42, uniform load, global y direction, negative means downwards, 21.5 meter. So the dead load application has been completed. So for your understanding, I am doing like this. So the next load 4 is live load. Okay. So roof live load. In our example, what is the value? Example 0.6. Okay. So 0.6 into tributary 5.375, that is 0.6 into 5.375. That is 3.225 kilonewton per meter. So where it has to be applied? On the rafter, because it is roof live load. So therefore it has to be applied in the roof, that is rafter. 5 to can anyone tell me what I have missed here? By intentionally, I have missed one line.
Member load.
Sorry.
Member load.
Yeah, exactly. Member load. Some members will get doubt. Already, sir, we have used member load here. Will it be applicable to this one? No. Why not? Because you have here, you have mentioned a load here. You have created a load case here. Okay. This member load command will be ended with this one, because you have created a fresh load case here. That is why you need to create again member load. Right. Now the same thing for mezzanine also. 5 kilonewton per meter square into 5.3 something. If you observe in the IS 800, there are load combinations for live load. Two types of load combinations actually. Okay. So one is leading and one is accompanying. Anyone observed that one? In IS 800, anyone observed? Two types of load combinations for live load. I'm asking. Just I'm going to show you that thing. Yeah, these are the combinations, right? Anyone have gone through this?
Yes,
Right. So, yeah, this is LSM combinations. This is working stress method. Limit state method is the first one for strength, and serviceability means working stress method. Okay. So these are the combinations which are mentioned in table 4 of IS 800 2007. So if you go through these combinations, there are two types of live loads. One is leading and accompanying. Okay, leading is the main live load and accompanying is the secondary live load. Okay, if you go through the point 1 here, when action of different live loads is simultaneously considered, the leading live load shall be considered to be causing the higher load effects in the member or section. Clear? So there are two types of live loads. One is leading and accompanying. Okay. So 1.5 is for leading and accompanying is for 1.05. So which one is critical? 1.5 is the critical. Most of the companies will follow only one, which is the critical. 1.5 only they will follow. That is why I am going to take roof live load and mezzanine live load in only one case, and I'm going to provide factor only 1.5. Okay. So that is why I'm taking mezzanine live load in this case only. I'm taking the critical for both. Clear? 5 into 5.375. It is 26.875. You guys can ask me if you have any doubt. 33 to 42 uniform global y direction negative 26.875, right? Till here, you guys have any doubts? No. So clear. And the next load you have to apply is load 5 wind, or you can say wind load WL1. Okay, because there is no collateral load option in the IS code. Whatever the collateral load comes, okay, that comes under additional dead load, which is included in the dead load itself. Okay, so and the next thing you are going to give is wind load 1, and there are 6 wind loads as we have discussed. If you have practiced, you will get to know how the wind coefficients. So I think you guys going through the recordings also, right? My thinking is correct. Have you gone through the recordings?
Yes, sir, we are going to.
So this is the internal pressure coefficient, which is for openings less than 5%. And if you have openings about 5 to 20%, the internal pressure coefficient will be 0.5 instead of 0.2. It will be 0.5 if you have openings about 5 to 20%. And if you have more openings, nothing but more than 20% openings in a wall, you will get about internal coefficients about, I think, 0.7. So, okay, internal coefficient is 0.7. So 0.2 is less than 5% openings. 0.5 is 5 to 20% openings, and 0.7 is more than 20% openings. Like that, Indian code providing some provisions. So if you guys go through all these things, you'll practice, you'll get. So I'm stopping today's session here. Just I'm deleting this note. I'm stopping today's session here. So I want to give you this file. Okay. Whatever the stat file I have done, I want to provide you. And could you please do it yourself? Can I expect like that? Can you complete it?
Yes, sir. Yes, sir.
Better, right?
Yes, sir.
Yes, sir.
Yeah, right. So I am provide. Yeah, yes, just tell me.
Wind load, I don't.
Wind load?
Wind load, I don't know how to do it.
How to apply wind load, you don't know, right? You have this sheet, right?
No, sir, I don't have it.
Sir,
Sorry.
we don't have wind load sheet as per American code. We have only as per Indian code.
No, this is the Indian code only, no? I'm going to explain Indian code
Yes, sir,
only.
but in last class we did as per American code.
So
but
what
we
is
don't
the
have-
difference? What is the difference, you think?
Calculation, sir. Only calculation factors, sir. Like
So already we have calculated wind sheet here. Already you have net coefficients here for wall and for roof. You have here. Just I'm not forcing you to do. Just try to do. Anyway, I'll continue this in the next class. That is not at all problem. I'll continue in the next class. Just try to do. Can I expect like that? You'll try.
Yes, sir. We will try to do, but I want to ask the please share the sheet also.
Excel sheets.
I think win
Need Excel
coefficient
sheet.
sheets I have shared, right? Win coefficient sheet.
Yes, sir. You shared, but in that sheet only as per Indian code we got.
So if you
Yeah.
don't mind again one time. Yes,
Okay, okay, fine.
It is based on we have to do only the Indian code only, no need AC code. This
No,
is
no, no,
Indian
no.
code.
Just again telling you, this is completely Indian code. Whatever
yeah.
I am doing in this frame, this is completely Indian code. You will not touch ASC code.
Oh yes, sir. We have to do exercise on Indian
Because
code
you
only.
people asked me, right? You people asked me. Someone asked, sir, could you please tell with AISC code? Some people asked me that, could you please tell me regarding this one, regarding this IS code, like that you people asked me. So that I am covering all those things. Okay. So if you want, I will give you some like what I have done, that I have file also, American code file. That thing and this sheet and this partial file. This is the partial file, right? I have not completed this file. This is the partial file, and I'll give these files also. Clear? Just try to do things, and we'll see in the next class. Okay.
Okay, sir.
So I'm
Thank
going
you.
to share all these files with you. Just try to do it your own. If not, then we'll see in the next class.
Okay, sir.
Okay. Thank you one and all for joining. Thank you. Have a good day. Bye.
Thank you, sir.
Bye.